let us continue with the problem which we were solving in the previous class. So now we determine the maximum bending moment to find maximum bending moment at C. The problem we considered was a simply supported beam of span 20 meters. It has been asked to find the maximum bending moment at a section C, which is at a distance 8 meters from left end. Total span of the beam is 20 meters when it is subjected to a moving load as shown in figure. There are 4 loads, 1, 2, 3, 4. So left extreme load is 1, right extreme load is 4. So the magnitude of these loads are 50, 100, 70, 200 kilonewtons. This is the problem we have considered. Now let us determine the maximum bending moment at any section of the beam. The procedure is same. So here the criterion, first let us state what is the criterion required for finding the maximum bending moment at any section. The criterion for finding maximum bending moment at any section of the beam is that the section should divide. It is that the section should divide the load and span. The load and span. That is this load and the span that this section should divide in same ratio. That is the criterion which I have told in the theory. So this, in other words, if the average load on left of the section is equal to the average load on the right of section, then we can just conclude that so this particular criterion satisfies. So here we adopt that. When left section of the average load on the left, average load on the right, when they are equal, then automatically the section will divide the load as well as the span in same ratio. We can just conclude. So that particular thing here we adopt. Instead of placing the load at C, the placing of the load at section C should be such that the average load on left and right should be same. Or in other words, the average load on left of section, we say WL, average load on left of section, and average load on right of section, that we call WR. Average load on left and average load on right of section should be same whenever the given load goes on B. So to arrive at that, we allow the loads to cross this section C one by one, either from left or from right, one by one. If you take the load to cross the section from left to right, then you have to place first the right extreme load at C, first trial. Then you have to go on allowing one by one, go on finding average loads on either side of the section, dividing the total load on left and right side of the section by the spans, whatever is there. Right? If you are allowing the load to move from right to left, then you place first initially the left extreme load at suction. So this is what you have to do. Either you can allow the load to move from right to left or left to right. So both should give same solution. Only thing is, initially you have to make sure whenever you are allowing from left to right or right to left, then all loads should be on this span. That you have to make sure. That is very important thing. Here, the total length of load is 9 meters, whereas the section is 8 meters from left. So if I allow the load to move from left to right, for first trial, when I keep this right extreme load and see one of the load will go out of the span, so that particular thing we should not consider. Of course, even if you do it, it doesn't matter. But first, it will give a sort of confusion. So let us take the load move from right to left. So I am giving a clue that whenever you are placing for the first trial, all the loads, by considering either moving from left to right or right to left, you see that all the loads occupies the span. So here, only all the loads will occupy the span only if you consider from right to left. That you take. Otherwise, you do both the cases and see that both the results are same. So, instead to avoid that both the cases, only one load case, this is the shortcut which I have mentioned. That to make sure all loads for the first trial will lie on the span. So that you just note. So let us allow the load. Let us allow the loads to move from right to left with the left extreme load, with the left extreme load on the section for first trial, and make sure, in the brackets you can say, make sure all loads lie on the span during first trial. That. So this indicates that why I am not considering the first case as from left to right. Because if I consider left to right, then when I keep the right extreme load for that particular case, then all loads will not occupy this span. That's the thing that you have to remember. So now you prepare the table. So load crossing point C. So first trial you consider all loads to be on the right side and allow the load to move from right to left. First load has to be 50 kilonewtons or load 1, which is 50 kilonewtons. Then you consider WL, WR, which I have defined here, sum of the average load on left side and average load on right side. Then you find the marks. So here, whenever a load is crossing C, so that particular load we have to consider on the other side. First I am placing here the load 50 kilonewton load here at C, and all other loads will be there just behind it, like that. So this is the position of the load 1, 2, 3, 4. For the first trial, it has to be like that. So whenever the say load is crossing the point C, that particular load has to be considered on the other side of the section. That is load 1 crossing So the average load on left side now, it will be 50 into divided by 5. Not 5, 8. Correct?
Distance.
First load, I am considering crossing is 50 kilonewton. So average load on left side will be 50 by 8. This will be 6.2, I say. Then on right side, it is 100 plus 70 plus 200, that is 370 divided by 12. That is
30.8.
30.8. 30.8,
Yes, sir.
Okay, that's right. So this, in the mass column, we are finding WL is less than W off. So this, whenever we consider other loads, then that particular inequality has to change. Then only we say that it passes through 0, that they are equal, WL will be equal to WR at that point. So this criteria will be satisfied. So this criteria you are satisfying in the form of table calculation like this. So then to consider second load crossing, point C is second, that is 100 kilonewtons. So that 100 have to consider on the next line. So here on left side WL will be 150 divided by 8, that is
18.7.
18.7. So on the right side, it will be 270 divided by 12.
22.5.
22.5. So again, WL is less than WR. You consider now the next load to cross the point C. That is third load, that is 70 kilonewtons. So you allow that. When 70 crosses, see the average load on left side will be 150 plus 70. It will be 220 divided by 8. That is
27.5.
27.5.
7.5.
Then on right side, it is just 200 by 12, 16.7. Now WL is greater than WR. So the load sign changes. So that means WL will be equal to WR when this load is about to cross. About to cross. Either left or just right. So hence the critical position. Hence the critical position of loads for maximum bending moment at C is when it has to be when 70 kilonewton load occupies C. So that is the conclusion. First you have to make. You have to ascertain the position of the load satisfying the criteria. This you have to follow in all the problems for finding the maximum bending moment at any cross section. It's a very simple, straightforward process. This you have to remember and you have to state all those things. So that means now the position of the load to get maximum bending moment at section C has to be that load 3 has to be at this point, and other two loads we would have crossed the span 2, 1, that is 50, 100, and 200 will be still on the right side. This is the fourth load. So this is the position of load to get maximum bending moment at C. Now you use your influence line diagram for finding the moment at the point C. That is your maximum bending moment at the section C. This is what I have dictated. So with the example, I am just explaining. I hope I made the points very clear. So now the influence line diagram for bending moment will look like this. So it is a triangle having maximum ordinate at the point under consideration. This is that. Right? This is ILD for MC, that is maximum bending moment. So this ordinate is Y3, this is Y2, this is Y1, this is Y4. You have to compute these things now. So Y3 will be equal to AB by L. A is 8 meters, B is 12 meters, that is 8 into 12 divided by L, that is
4.8.
4.8. Okay? So you got the ordinate here. The other ordinate from similar triangles, you can do it. Therefore, this Y3 divided by, if I take left side, by this similar triangle, Y3 divided by this 8 should be equal to Y2 divided by this distance, that is 8 minus 2, that is 6, that is equal to Y1 divided by this distance, that is 8 minus 5. 3 plus 2, 5 I have to subtract.
3.
So that is 5. So therefore, Y2 is equal to,
Sorry, 8 minus 5.
pardon?
Y1 divided by 8 minus 5.
8 minus 5, 3.
3.
Yes. This 8 minus 5, correct. 3. So therefore, Y2 is equal to this, Y3 is 4.8 divided by 8, that is 0.6 into 6, that is 3.6. And similarly, Y1 is equal to this, 4.8 is your Y3 divided by 8, that is 0.6 into 3, that is 1.8. Then you take this similar triangle for finding Y4. So again, Y3 divided by 12. It is this. It should be equal to your Y4 divided by, this is 4 meters, 12 minus 4, that is equal to 8. Therefore, Y4 is equal to, Y3 is 4.8 divided by 12, that is 0.4. 0.4 into 8, that is equal to 3.2. So you got all the coordinates, you got all the loads, so you find MC. I have given the complete procedure now, how to compute the ordinates by similar triangles, everything. So don't do any mistake in this. Only by similar triangles you have to get the ordinates. After getting one of the ordinates, that's the maximum ordinate, that is known, AB by L, from that standard influence line diagram. So therefore, MC is equal to 50 into Y1, 1.8 plus 100 into Y2. Y2 is 3.6 plus 70 into Y3. Y3 is 4.8 plus 200 into Y4, 3.2. So this is equal to 90. This is equal to 360. This is equal to 336. This is equal to 640. So total, this is equal to
1426.
1426 kilometer. Hence, maximum bending moment at C is equal to 1426. That's how to find maximum bending moment at any point. You can follow this procedure, so it is easy, right? In 20 minutes, 15 to 20 minutes, you can solve it, one full question. that is, or along with another one, right? So you can try whether you are going to get the same load by allowing it to move from left to right. So I just as a curiosity say, I will give here, suppose if I say the first crossing the load from left to right is load 4.
Yes.
Because it has, right extreme load has to be placed there.
4.
So if I place 4 there, then here average load on left side will be 200 by 8. Right?
On the right side, that is.
No, I am allowing, suppose you consider, this is only extra thing, it is nothing to do with this, only one case you can consider, allowing load to move from left to right. Left to right. Here I have considered from right to
Right
left.
to left.
Here now let us consider from left to right. So you prepare the same type of table, load crossing, point C, then WL, WR, then remarks. Right? So load crossing, first I have to place when it is from left to right, 200 kilonewton load has to be placed at C first. So here WL will be 150 plus 70, that is 220 divided by 8, that is
27.5.
huh?
27.5.
27.5. I think you are getting that particular figures here also. It has to be same. There is no other call. So this I am considering all the loads. Right? Naturally, because when I say 200, they are considering on the other side. So naturally, all the loads will come. Suppose if you have one more load, then it may not give maximum result. Here, of course, you can consider both. Right? So
Sir,
here,
that is the thing.
it will be 200 divided by 12, that is,
Sir, on left side, that 50 kilonewton will not come, right, sir? Only 170 divided by 8.
50, 100, 70.
When
So
we are
this
placing-
is crossing.
Oh, if we take
I
crossing.
have told what is the word I have used.
Yes, sir.
Road crossing. It has crossed.
Crossing.
It has crossed. Right? It has crossed. That is why I am considering that in that.
It's not on the point, it's
Not,
crossing.
but limiting I am considering on the, because the load, this particular thing, inequality changes its sign. So 0 will be towards
Yes,
back. That is why I have considered this. Right?
We are
On-
directly getting the last third one in here, sir. We are
Ah.
getting directly 16
But
points.
only just see, I'm just verifying, that's all. That's why though in the procedure I have given, you work both the cases. You need not do that, both the cases, because both will give the same result. That's what I wanted to show you here in this calculation. This you need not do, only one case you can do. Don't waste time on the other, this other case. Just I am showing, right? But here you have that doubt. One load will go out. That is why I didn't consider that. Now I am showing that also it considers. So here it is
16
200 by 12, 16.7.
7.
So here WL
Greater
greater than WR. Here it is less. Now here it is greater. Exactly opposite thing will happen. Next, you consider load crossing 70. Right? So 70 means here it will be 150 divided by
8.
18.7.
18.7.
7. So here this will be 270 divided by 12.
22.5.
30.
22.5.
22.5. So now you see WL less than WR. That means load 70 has to be placed at point C.
Same.
So here also I got the same thing.
So 7.
So both should. So then once you arrive at that particular thing, so to satisfy the criteria I have shown, you can allow load to move from left to right or right to left. You will get the same value. What calculation you can do it, right? So having arrived at that critical position, you draw the influence line diagram, get the ordinates. I have shown that full calculation for getting the ordinates, work out the maximum. bending moment at a section. So this is the simplest procedure. Next we will take up to find absolute maximum bending moment. Next step to work in.
Yes, sir.
Let us find absolute maximum bending moment in beam. This is absolute maximum bending moment or design bending moment for the beam. That is for design of beam, what is the maximum bending moment due to these moving loads. So the previous one was only at a section. See, now here for that entire beam, what is when this load is moving, what will be the maximum bending moment you are going to get. So these two are very, very important criteria or important problems which we should know. Others, of course, reaction and shear force is there, but these two generally it will appear in the examination either bending moment or absolute maximum bending moment. Here also first we have to state the criteria. So the absolute maximum bending moment for finding in the beam, we have to find first two criteria. One is we have to arrive at a section in the beam where we can expect absolute maximum bending moment. Section in the span, the point in the beam where we can expect that. That's first criteria. Second is under which load maximum bending moment. The two criteria. One is load, other is location in the beam. Both. Of course, location in the beam is obvious, that is center point. Usually, you can expect the maximum bending moment at the center of span. So, location is no center. Next, load. Under which load the maximum bending moment occurs. So, for that, we have to repeat the process. Allow load to move either from left to right or right to left. We will get the same thing one by one, right? So, or you don't allow the load to move. You find the CG of the load, in other words. Find the CG of the load. That CG of the load is the maximum load. All the loads, resultant of all the loads. Then you find the loads which are very close to that CG line in the given train of loads. So suppose if the CG line comes here, that you have seen in the already we have done this calculation. The CG of the loads, it is at 5.8 meters or something from load 1. So that means the loads which are closer to this particular CG line is 70 and 200. But closest is 70.
Yes, sir.
Point something you will get because this is 5.8. Total load is 9 meters. So this will be 9 minus 5.8, that is
3.2.
3.2 meters. This is 4 meters. That means this CG line is from load 4 is 3.2 meters, but from load 3 it is just 0.8 meters.
Yes, sir.
That is 4 minus 3.2. So this is the closest one, but its magnitude is smaller. So we have a dilemma now. Out of these two closed loads, under which load? First thing is, you have to select the loads which are very close to CG line, center of load line. The center of load line we have arrived at. So there are two loads. Out of these two loads, one is very large, other is relatively smaller, you can say. But if they are of the same magnitude, then you can take closest way load with one calculation can come out. But in the procedure I have told, you can do the calculation for both the loads which will lie on either side I have given. The reason for that is this kind of situation, wherein there is vast difference between the two loads, and sometimes you may get maximum bending moment even with the load which is having a smaller magnitude. So that to avoid that confusion, I have given the procedure as you select a load which is laying on both sides of the center of the line, and that load you keep it at a distance either from left side or right side. This left side load you take its distance from the right end, and for this right side load you take the distance from the right end, and you place these loads in the beam at a distance is equal to half the span, which corresponds to your center of span, minus that eccentricity, half the eccentricity of the load. That means you are placing that load and CG of the load at equidistance from center of span. That is the criterion to get the maximum bending moment. So to get the maximum bending moment, absolute maximum bending moment, it will occur always at under a load which is closer to center of the load, and that load we have to keep it at equidistance, that center of the load as well as that particular load at equidistance from the center of span. Because I told you the two criteria is the location in the beam, which is center of the point, and the load under which we have to place similar to the center. Like these 2 points have to fit. That you state here. So to get absolute, straight away I will give that, to get the absolute maximum bending moment, we have to first find centroid of loads, centroid of moving loads, centroid of moving loads, and the loads which are closest, and the loads which are closest on left and right of the centroid. Okay, centroid has to be established. Has to be established. So let EL and ER be the distance of loads on left, closest load, distance of closest loads on left and right. Let EL and ER be the distance of closest loads on left and right of centroid. So that means, so here we have to find the centroid. This is node 4, 3, 2, 1. So this is CG of loads. So that we have already done the calculation. All we can do here, this will be 5.8, this is 3.2, and this we call it as ER, and this is EL, which is 0.8. This you have to establish. So on left and right side. Then place the left load at a distance x is equal to L by 2 minus EL by 2. That is, we are placing that load symmetrically above the center like that. Load and centroid load will be at equal distance. At distance, x equals L by 2 as EL by 2 from left end. They are all from left end only. From left end. A. That is like this. So here it is, of course, that also I will write it. This value will be L by 2 is 10 meters. EL by 2 is this 0.8 divided by 2. That is 0.4. That is 9.6 meters. So here I have to place this load
3.
3. That's what load 3 at a distance 9.6
9.6 meters.
meters, and this will be 20 minus 9.6, 10.4 meters. You see the location, you have to fix first. You see that load 3 or 70 kilonewton. Then you arrange the other loads with respect to this. So the other load 4 will be at 4 meters, and other 2 loads will be here. Load 2 is 2 meters from here. This is 100. So this is 50, which is at 3 meters. So this is at 4 meters. So this is the position of load to get absolute maximum. That is one of the positions. Other position, you have to take x equals L by 2 minus ER by 2. Right? Both you do the calculation. Whichever gives you the maximum, that is the absolute maximum. So this is a very important thing which you have to remember. Then in finding the maximum minimum, you are preparing the table. Here the criteria is this. So this, if you have understood, absolutely things are very, very simple. So this location, if you know, then for this position, you work out use the influence line diagram, work out the bending moment. So for this position, next we continue. So this is the position of load. This is position of load to get maximum bending moment under 70 kilonewton load, because you will get the absolute maximum bending moment either under load 70 or 200. If there is vast difference, then if this maximum load, magnitude of the load is more, that is closer to the center, then absolutely you can do with one calculation. You select that. Or if the difference is not much, if they are equal, then the nearest wheel load, you can take it, do that. Suppose both are 70, 70, then this is nearer, so only one calculation will do. Otherwise, when there is difference between the two loads which are closer to the centroid, if the difference is too much, if you feel it is too much, here I feel it is too much because this is almost more than 50%. So that is why I will examine both the things and do that. There may be small difference, that's all. Otherwise, even if you do one thing, there may not be much vast difference in the final result, but you don't get exact result. Right? That's all you have to remember. So this is the maximum load under 70 kilonewton for this position. For this position, the ILD is as shown below. So you take that ILD and calculate the ordinates and work out the maximum weight. So here, the ILD, we are determining under this load, 70. Mind it, I have told here under 70 kilonewton load, right? So you will get a triangle. This is load 3 point. So this is A point, this is B point, and this distance is 9.6, and this is A now, this is B 10.4, right? So therefore this ordinate is y3, and your load here is 70 kilonewtons, and here you have that other load 200 kilonewtons, and this is that load 4, and that ordinate is y4, and this distance is 4 meters, correct?
Yes, sir.
and other two loads will be here, the ordinates. So this is y2, this is y1, the other load is, so this is that 100 kilonewton load, this is that 50 kilonewton load. So where that load, where you have to find out is this distance from that. That's all you have to remember. So this is that IIT. IIT to get maximum bending moment under 70 kilonewton load, under a given load. So this Y3 will be AB by L, that is influence line diagram system, that is 9.6 into 10.4 divided by 20.
4.9.
4.9.
9.
5,
9.
9. So Y3 is 4.9, then we have Y3 divided by 9.6 is equal to Y2 by, right, this distance, that is 9.6 minus 2 meters.
Minus 2. 7.6.
7.6. That should be equal to Y1 divided by that 7.6 minus 3.
4.6.
Right? Therefore, your Y2 will be equal to, this Y3 is 4.9 into 7.6 divided by 9.6.
3.8.
3.8, and Y1 equals is 4.6 into
4.9 into
4.9 into 4.6 divided by 9.6.
2.3.
2.3.
3. Yes, sir.
Okay. Then also you take other similar triangle. Right? So there this Y3 divided by 10.4 is equal to this ordinate Y4 divided by, this is 10.4 minus 4, that is 6.4. 6.4, correct.
Yes, sir.
6.4 plus 4, 10.4. Therefore, Y4 is equal to, Y3 is 4.9 into 6.4 divided by 10.4. So this is
3.
Huh?
3.01. 3.
3, yeah?
Yes, sir.
Okay. So hence, we can work out the absolute maximum bending moment for first load. Hence, absolute maximum bending moment under 70 kilonewton load is equal to, so you can work out this first 50 into Y1. Y1 is 2.3,
2.3.
then plus 100 into Y2 3.8 plus 70 into Y3, it is 4.9, then 200 into Y4, that is 3. You can simplify this, you will get the
1438.
1438
38. Yes, sir.
kilonewton meter. Right? So on that 70 kilonewton, you are getting this. So usually the load which is closer to central, here this 70 kilonewton load is closer to central, I have established. So but I have doubt there with other load, that also you can compute and see that whichever is more when you have a doubt. Otherwise with one load, if they are of same magnitude, right, you can just do with one calculation. But here I have a doubt now. This is about twice this. That is why better work with that also. That is the procedure I have given. Better work to be on the safer side, both the loads on either side, and come out with the exact absolute maximum minimum. Otherwise, you can select only the closest load. Right? Here we will do for the other one also. So that is only the bracket, that's only extra. right? So this you have to be careful. This is about absolute maximum bending moment and bending moment at any section. This, if it is very clear, there is nothing in this. Any problem, if there's let them say, we can come out with the solution. They may not ask all the 4 cases, only these 2, any 2. And preferably this bending moment and absolute maximum bending. Right? So here, so second case, to find absolute maximum bending moment under 200 kilonewton load. So this also they may ask, they may give any load, find the maximum bending moment under the load. For that also you have to do the same calculation. First find the CG, find the distance of that load under which you have to determine maximum bending moment from the CG of the load. Then you place that load at a distance is equal to L by 2 minus that eccentricity by 2. So place that load at that part, either from left or right, you work out and calculate the bending moment. That's all. Under a load, that also you can do it. So here, place the load 200 kilonewton at a distance. Since this 200 kilonewton load is on right side of CG line, from right side, so at a distance x is equal to L by 2 minus ER by 2 from right end. Since it is right side load, from right end you place right end B. That is x equals 10 minus ER by 2. ER is how much? We worked out here ER 3.2. This is ER. I have it on here. ER. That is 3.2 by 2. That is equal to 1.6. That is 8.4 meters. So that means your load, that 200 kilonewton load 4, 200 kilonewton, that you have to place at a distance from right side equal to 8.4 meters. Since it is 8.4 from right side B, from left side it is at a distance is equal to 20 minus 8.4, 11.6 meters. Now we can arrange other loads. So from here, load 3 is at 4 meters, load 3, that is 70, then load 100, that is 2 at 2 meters, then load 50, which is at 3 meters. Right? You arrange it like that. Then you draw the ILD under the load 200 kilonewtons. So this is that ILD. It looks like that. So this is your Y4, then Y3, Y2, Y1. So you can work out Y4 is equal to AB by L. That is 11.6 into 8.4 divided by 20. I am doing 2 times calculation. That's extra. So this is 4.8. More or less it is same value. More or less. Here also Y3 4.9, 4.8. So this is more, though it is 70 kilonewton. So there you are getting, let us work out the magnitude, I am not sure. It all depends upon that ordinate value. That will change a little bit. So then, when this is known, so you have this Y4 divided by 11.6 is equal to this Y3 divided by this distance, which is nothing but 11.6 minus 4, that is 7.6. That is equal to Y2 divided by 11.6 minus 2. 5.6. That is 5.6. That is equal to Y1 divided by 2.6. Yes. 5.6 minus 3.
3, 2.6.
Therefore, you can work out other ordinates. y1 equals 2.6 into 4.8 divided by 11.6. I am giving all the calculation.
1.0.
Huh?
1.0.
1.0. Okay, y2 is 5.6 into 4.8 divided by 11.6. How much?
2.3.
2.3.
3.
Then lastly, you can work out y3 also. y3 equals 7.6 into 4.8 divided by 11.6.
3.1.
3.1. So you know the ordinates, you work out hence absolute maximum bending moment under 200 kilonewton load is equal to, first you take 50 into y1 1 plus 100 into y2 2.3 plus 70 into y3, that is 3.1. 3.1. Then plus 200 into 4.8. So
1457.
1457 kilonewton. See, this is more.
That is 1428.
Here it is 1428.
28.
So this is
1457.
so hence that's why I told you to do both the calculation. Variation may not be that much. Magnitude of variation 1426 and 1457. Difference is not much, but still the doubt is there because though it is nearest, that's why I didn't say nearest load. We can state that nearest load provided if the magnitude of the load they are more or less same. Otherwise, if there is vast
Even though
difference,
for smaller magnitude, we are getting nearby values, sir. 1428.
that's it.
It
Anyway,
depends on distance.
so better do for both. Otherwise, if they are of same value, by chance if you see in the problem, then with one calculation you can do it. Otherwise, both you have to do. Hence that. Out of these two, here you are finding this. That's why both the cases you have to do it. So I didn't state that, though in the book they state that, so the maximum bending moment, absolute maximum bending moment occurs under the load which is closer to the CG load. So that is not happening here. Though that 70 kilonewton is closer, it is happening at 200 kilonewton. That's why I told you for both loads, on left and right, you do the calculation that is safe always. If they are of same, then you can just write a line, since they are of same magnitude, left and right. So not very much, so maximum occur at the nearest load and come out. This is about absolute maximum bending moment and bending moment at any surface. So the last thing is shear force. So reaction we have completed, only shear force at any section. We will take that.